At exactly 10 minutes past midnight, the Pacific Northwest coastline remains one of the quietest geological zones on the planet. To an untrained observer, this silence suggests stability and peace along the rugged shores of Oregon and Washington. But for those monitoring the deep telemetry of the Earth, this stillness is a warning. It is the sound of a massive geological debt that has been accumulating interest for 325 years. Welcome to your nightly briefing on Terra Alerts. Tonight, we are examining the Cascadia Subduction Zone, a 700-mile megathrust fault that is currently locked and loading. This fault stretches from the northern tip of Vancouver Island down to Cape Mendocino in California. It is a boundary where the Juan de Fuca plate is being relentlessly forced beneath the North American plate. In California, the San Andreas fault is famous because it is active, frequently releasing pressure through small to moderate tremors that the public can feel. Cascadia is fundamentally different and far more dangerous. Our analysis of USGS data confirms that the Cascadia Subduction Zone produces almost no microseismicity. It does not creak or groan. It simply holds its breath while the tension builds to a breaking point. Seismologists refer to this as being fully locked. The two massive plates are snagged on one another, bending the crust of the Earth like a wooden bow being drawn back to its limit. Every year that passes without a release, the Juan de Fuca plate moves about 40 millimeters deeper into the mantle. This translates to several meters of potential slip that is currently stored as elastic strain. This is not a matter of if the bow will break, but when. Current scientific projections suggest a 37% chance of a magnitude 8.0 event occurring within the next 50 years. Even more concerning is the 10 to 15% probability of a full rip. This would be a magnitude 9.0 or higher event, involving the entire length of the fault line simultaneously. To understand the scale of this threat, we have to look at the mechanics of a subduction zone, (OZ). Unlike strike-slip faults where plates slide past each other, subduction zones involve massive vertical displacement. When the tension finally overcomes the friction holding the plates in place, the North American plate will snap upward and outward. This movement displaces the entire column of the Pacific Ocean above it. This process is what creates the megathrust earthquakes that have defined the most destructive moments in modern history. We saw this in Sumatra in 2004 and again in Japan in 2011. However, the Cascadia fault has been silent for much longer than the faults involved in those disasters. The last time this region experienced a major rupture was January 26, 1700. Since that night, the fault has been accumulating energy without any significant release. We are currently standing in a danger window that has historically signaled the approach of a catastrophic failure. Geodetic GPS stations across the Pacific Northwest show the land is actually being pushed inland and upward. This deformation is a physical manifestation of the pressure building miles beneath the surface. Inland cities like Portland, Seattle, and Vancouver are being slowly compressed. The geography itself is being reshaped by the sheer force of the Juan de Fuca plate pushing against the continent. Our interpretation of the latest geological mapping suggests that the fault may be more segmented than previously believed. While this could mean smaller individual quakes, it often results in a higher frequency of events on the southern end. This southern section, near the Oregon and California border, has a much shorter recurrence interval. It is the most likely candidate for the initial rupture that could trigger a domino effect along the entire coast. Experts at NOAA and the USGS are watching these specific coordinates with increasing concern. They are monitoring for any subtle changes in seafloor temperature or chemical composition that might signal a shift. But the reality is that Cascadia gives very little warning, because it does not produce the small clusters of tremors seen in other zones. The first sign of trouble will be the main event itself. Imagine a 700-mile stretch of the Earth's crust snapping all at once. The energy released would be thousands of times greater than the atomic bombs used in the 20th century. This is the silent reality facing the millions of people living in the I-5 corridor. They are unknowingly participating in a massive geological experiment where the variables are controlled by tectonic plates. Scientists are not just worried about the shaking, but the duration of the event. While most earthquakes last for 30 seconds, a Cascadia full rip will involve 6 minutes of continuous violent motion. This duration creates a structural fatigue that most modern buildings in the United States were never designed to withstand. It is a slow-motion demolition of the region's entire infrastructure. As we look closer at the data, the picture becomes even more unsettling. The lack of microseismicity means we are flying blind, relying on historical analogs to predict a future catastrophe. We are currently living through the longest period of silence this fault has seen in several cycles. The debt is deep, and the Earth is a very persistent collector. But how do we know the date of the last great quake if there were no written records in the region in 1700? The answer lies in a series of unlikely witnesses that scientists only recently discovered. These witnesses tell a story of a night when the ocean rose and the forests died in an instant. It is a detective story that spans the entire Pacific Ocean, linking a quiet coast to a distant disaster. The first witness stands along the coast of Oregon and Washington, where the skeletons of ancient western red cedars rise from the salt marshes. These silvered remains are known as the ghost forests. In the late 1980s, geologists noticed something strange about these trees. They did not die of old age or disease, but were drowned where they stood while still in their prime. Scientific analysis of the growth rings reveals they all stopped growing during the winter of 1699. The land beneath them dropped several feet in a single, massive seismic event. This sudden subsidence allowed the Pacific Ocean to rush inland, poisoning the roots with salt water. It was a regional collapse that occurred simultaneously across hundreds of miles of the Pacific coastline. While no settlers recorded the event here, a second witness was documenting it in Japan. On the morning of January 27, 1700, a 5-meter wall of water struck their shore. Local officials recorded it as an orphan tsunami. There had been no tremor or warning to explain the sudden, destructive surge of the sea that destroyed coastal villages without any local earthquake. For 3 centuries, this event remained a historical mystery in Japanese records. It wasn't until the 1990s that scientists used wave physics to trace the surge back to its origin. By calculating the speed of the water across the deep ocean, researchers found the exact moment of the rupture. The clock stopped at 9:00 p.m. on January 26, 1700. This precision allows us to finally understand the scale of our situation. The Cascadia Subduction Zone is not a theory. It is a recurring nightmare with a verified historical timestamp. The third witness used the power of oral tradition. For hundreds of years, the Huwupu and Quileute tribes told stories of a battle between the Thunderbird and the Great Whale. These legends spoke of a great shaking that lasted long enough to make people sick. They described a flood that washed away entire villages, carrying people into the darkness of the night. Western science ignored these testimonies for generations, dismissing them as folklore. Now we realize these are the most accurate survival reports from the last full rip of the fault. When we talk about a full rip, we aren't describing a typical earthquake. We are describing a physical event that defies modern American experience and all existing building codes. Most earthquakes you see on the news last for 60 seconds. A magnitude 9 event on the Cascadia Fault will involve violent, continuous shaking for 3 to 6 minutes. This duration effect leads to the catastrophic failure of modern structures. It is the relentless fatigue of materials as the ground rolls like the surface of the ocean for several minutes. During those 6 minutes, the ground acceleration could exceed 1 g. This represents a force stronger than gravity, literally launching unanchored objects and people into the air with every shift. Think about the physics of that moment. The very ground you stand on becomes a weapon. moving with such violence that it overcomes the weight of everything on its surface. As the shaking continues, the coastline will undergo a permanent geological shift. The North American plate, which has been bulging upward for centuries, will finally snap and sink. Our analysis suggests a permanent subsidence of up to 7 feet across the region. This is not a temporary flood. It is the sea claiming the land for eternity. Coastal towns that are dry today will become tidal marshes by the time the shaking stops. The geography of the Pacific Northwest will be redrawn in a single afternoon. This happens before the first wave even arrives. Once the seabed shifts, it will displace a massive volume of water, sending a tsunami toward the shore in 15 minutes. There will be no time for official evacuation orders. In this scenario, the shaking of the earth is the only warning the residents of the coast will ever receive. The height of these waves could reach 100 feet in some locations. It is a wall of water carrying the debris of everything the ocean has already reclaimed. But the physical destruction along the coast is only the first layer of this catastrophe. The true complexity emerges when we look inland, toward the critical systems we have built. We must look at the critical energy infrastructure hub in North Portland. This 6-mile stretch of industrial land holds 90% of Oregon's liquid fuel and all of its jet fuel. This entire facility sits on liquefiable soil. When the ground turns to liquid during the shaking, these massive steel tanks will not remain stable or upright. Our interpretation indicates they will tip, sink, or float like toys in a bathtub. This creates a man-made chain reaction that researchers are only now beginning to quantify. We are looking at a secondary disaster that could dwarf the initial impact. The resulting fuel spill could reach 20 times the size of the Exxon Valdez disaster. If this fuel ignites, it creates a river of fire on the Willamette River. This fire could spread to the largest urban forest in the nation, creating an unstoppable blaze. Tanks containing anhydrous ammonia and chlorine gas are also at high risk of rupture. These toxic gases would drift silently into residential neighborhoods, complicating an already impossible rescue effort. This toxic plume would follow the low-lying terrain, creating a chemical death trap for those unable to flee. According to research, this represents a systemic collapse. The Critical Energy Infrastructure Hub, or CEI Hub, is a 6-mile stretch of industrial land. It holds 90% of Oregon's fuel and all jet fuel. The problem lies beneath the steel. The facility sits on liquefiable soil, a ticking clock that scientists confirm will fail during a magnitude 9 event. When shaking exceeds 3 minutes, this land will turn into a thick liquid. Massive storage tanks will tilt, sink, or float away on shifting silt. Estimates suggest 194 million gallons of fuel could be released. That is 20 times the volume of the Exxon Valdez oil spill. This spill would not stay in water. Much of this fuel would likely ignite, creating a catastrophic river of fire moving toward the Columbia River. Nearby Forest Park, the nation's largest urban forest, would be at extreme risk of firestorm. The water lines and road networks required would be completely severed. Beyond flames, the chemical threat is the silent killer. Tanks containing anhydrous ammonia and chlorine gas are critical for industrial refrigeration and city water treatment. These gases are heavier than air. Instead of dissipating, they would crawl along the ground, flooding residential basements in the Linton and St. John's neighborhoods. This is the second disaster that early models failed to grasp. We aren't just looking at Earth moving, we are looking at total industrial failure. Our analysis suggests the United States is roughly a millennium behind Japan in seismic resilience. Following the 2011 earthquake, Japan invested billions in reinforced seawalls. In the American West, strict building codes only became standard in the mid-1990s. This leaves thousands of brick buildings vulnerable to total collapse during shaking. Soft-story apartments are especially prone to pancaking during sustained shaking. These structures are common throughout the major cities of the Pacific Northwest and Cascadia region. the duration of shaking changes physics of disaster. Most people expect 30-second tremors, but a full rip of Cascadia will last over 5 minutes. This creates a fatigue effect on steel and concrete. Structures surviving the first minute of motion will eventually reach their breaking point as energy continues pounding. During this time, the ground acceleration could exceed 1 g. This force is powerful enough to overcome gravity, effectively throwing heavy objects into the air. Once shaking stops, the geography of the coastline will be fundamentally altered. The subducting plate will cause the coast to permanently drop by 7 feet. Areas that are currently dry land will become permanent tidal zones overnight. Roads, houses, and entire town centers will be reclaimed by the Pacific Ocean. This subsidence will happen before the first tsunami wave arrives. Within 20 minutes, the ocean will rush in to fill the landscape at 80 feet. For coastal residents, there will be no official siren. The duration of the earthquake itself is the only warning they will receive to reach high ground. Further inland, infrastructure collapse will turn the I-5 corridor into isolated islands. FEMA's Cascadia Rising exercises revealed that hundreds of bridges will likely be impassable. This means that ground-based relief efforts from the east will be nearly impossible for weeks. The Pacific Northwest must be supplied by sea or air. Emergency managers have recently pivoted their advice. The old 72-hour kit is no longer considered sufficient for the reality of a modern Cascadia subduction event. The current 2 weeks ready campaign reflects the grim reality of our grids. In many coastal communities, power could be out for a full year. Clean water may not return for 3 years. We are living through a period of quiet accumulation that most of the world continues to ignore. The silence of the fault is not stability, but a 325-year-old debt waiting to be collected in a single afternoon of destruction. Data indicates the window for a magnitude 9 rip is open. Whether it happens tonight, the geological pressure is reaching a violent breaking point. Our goal at TERRA ALERT is to ensure you watch the signals others miss. Understanding the scale is the first step in surviving this event. Statements about potential future events represent our own analysis. However, the existing data from USGS provides a clear roadmap for significant regional concern. If you found this briefing essential, consider supporting our work by subscribing and sharing this report. Your vigilance is our mission as we monitor. We will monitor global feeds throughout the night. If anomalies are detected, we will provide an immediate update. Stay informed, stay calm, and stay vigilant. This has been TERRA Alerts. We will see you in the next briefing.